Okay, so for this CFU, this is the Completing the Square. So in question one, I'll try and do it bit by bit. I don't have much space here, but firstly, for this, I'm just going to recap on Completing the Square. So if we've got any quadratic with a singular x, so if we've got effectively x squared plus bx plus c, we can write that in a form called Completing the Square, where we halve whatever the b is. So just remember, we just halve whatever b is, subtract whatever that is squared, and then we've still got the plus c at the end. So that's effectively the method that we'll be using here. So if y is x squared plus 8x, our first thing is to halve that 8 and put it inside the bracket. So we've got x plus 4, that's the squared. Then we're going to subtract that 4 squared, and then don't forget about the plus 10. I like to put this 4 in a brackets just so I remember not to use that minus just over there. I'm just going to correct that there. And then it's just tidying it up. So y equals x plus 4 all squared. This is minus 16 plus 10 gives me minus 6. Big thing to remember again about completing the square, just separate to the notation above, is once you've actually found it in this notation, so x plus, let's do it minus just for now. So x minus p all squared plus q. Once you've found y in this form, this will tell you the minimum or maximum point, and that will always be at pq. So just be aware that the p has actually changed sign, and the q is just the same as whatever sign it was here. So here it's positive, so it's positive. So in this case, my minimum point, or the turning point, will be given by minus 4 and minus 6. So that's the very bottom part of my graph, and that'll help when we come to sketching. Question 2 then, same idea. I'm just going to kind of go through a little bit more. The harder these get, it's just with numbers now. So f of x is equal to, open up your bracket, remember that's squared, we're going to minus something, squared, and then we've got this plus 19. So all I need to do is fill in those blanks. Half of 8 is 4, so it's a minus 4. In here it's minus 4. You should really put the minus in here as well, just so you understand what's going on here. It doesn't actually matter. So when we do minus 4 times minus 4, it's the same as 4 squared. So this really doesn't matter if this is a 4 or a minus 4. On the next one, we've got f of x is therefore equal to x minus 4 squared, and we just want to tidy this up. This is a minus 16, and then we've got a plus 19, so we've got a plus 3. So just to finish this off properly, I know that a is minus 4 and b is 3. So I'm just kind of giving the question what we're kind of pointing towards there. Question 3, same idea, pretty much exactly the same, just a slightly harder kind of question for numbers wise. So I'm going to start just by writing this out just so I can actually write this properly. So I've got this, and I want to say that that's equal to x minus 4, so that's half of 8 squared. I'm actually going to do this straight away here. So 4 squared is 16. Now I've got this minus 29. So I'm now taking it up a little level just so I'm doing that in one step. And I've got x minus 4 squared. And then I'm just going to have to work this out. So I've got minus 29, take away this. So that to me is a minus 45. And it's just saying finding the value of a and b. So again, I'm going to list those. So a, in this case, is equal to minus 4. And b is minus 45. Question 4, I feel I'm going to need a little bit more room, so I'm just going to cut this here. And for question 4, I'm just going to do it in this section here. So I've got 3x squared plus 9x plus 10, and it wants in the form 3 lots of a bracket plus some kind of constant. And so the first step to do here is to try and factorize. So you can't really complete the square unless you factorize and get a singular x squared. Now there's 2 ways of doing this. You can factorize every single term by what's in front of the x squared, or you can just do the first 2 terms. Now this is personal preference. I would say to look at all 3 terms. If they factorize, do them all. If not, just do the first two. So in this case, 10 doesn't divide by 3. So I'm just going to factorize out the first two. So I'm going to take a 3 out. And I'm actually going to use a square bracket just to emphasize this. So my 3 is times by x squared. And then I've got this plus 3x. So that's my first two terms. Then after the brackets, I've still got this plus 10. So what's going to happen here is I'm only completing the square on what's inside that kind of square bracket, and then I'll bring it all back together with the plus 10 towards the end. So I'm just going to bring my equals just over here now, just so I've got a bit more room. So if I had more space, it would have been better. So this is kind of bad maths now. So 3 inside my square bracket, I'm completing the square. So I've got x plus half of 3 is 3 over 2. And then that's squared. I want to subtract whatever that was, so 3 over 2. So I want to subtract 3 over 2 squared. And that's my square bracket. I can actually close that off now. And now I've got a plus 10. So this will be the exact same as x squared plus 3x. I can now just try and tidy that up. So I'm going to do it in 2 lines here. Apologies, AC's just come on. So this thing is minus 9, so 3 squared is 9, and 2 squared is 4. Now I've got this plus 10 kicking around on the outside. Multiplying by 3. So 3 times bracket is just 3 lots of that bracket. Not going to do anything too special there. And then 3 times this gives me minus 27 over 4. That's that bit all expanded now, and then I've just got this plus 10. So notice how the square bracket's now disappeared. I just need to tidy this up. Remember 10, I could have written as 40 over 4, just so I can start dealing with these fractions. So I'm just trying to deal with this as a non-calculator question. But if it is calculated, obviously, just use that to help. So 40 take away 27 is 13. So I've just got a positive 13 over 4. Again, it's just asking me for it in that form. So that is now complete. Lastly, question 5. You just need to solve it using completing the square. So it's slightly different here because it's set equal to 0. So the first thing I'm going to do is try and complete the square on this. So this time you'll notice that 2 can actually come out of each term. So I'm going to show you what happens if you do it for each term and how that differs to over here. Notice the square bracket was involved inside here. Now the square bracket is going to be on the outside. So again, just to emphasize, I'm going to use a square bracket. Normally I just use a curved one. So I've got x squared plus 6x minus, this time it's going to be 16. And that's still all equal to 0. So all I'm doing here is adjusting the left-hand side and complete the square there. So this time, keep the 2 on the outside and complete the square of what's on here now. So I've got x plus 3 squared. Don't forget to remove that 3 squared now. And then you've got this minus 16. All of that's still inside that square bracket, and it's equal to 0. Tidy that up a little bit. Sorry, I'm just going a little bit small here. So we've got x plus 3 all squared. Here we've got minus 9 and then minus 16, so that's minus 25. And that's equal to 0. Now what you do if you complete the square here is you'd actually times everything by 2. So you do 2 times this and 2 times this. So it would give you 2 lots of x plus 3 all squared minus 50. But because this is already equal to 0, I'm actually going to just divide through by 0. I'm going to start solving right at this point here. So I'm going to divide by 2 at this stage. So that leaves me with x plus 3 all squared minus 25 equals 0. I'm going to go one more step further. I'm going to take my 25 to the other side. I'm going to square root both sides to get x plus 3. Oh, apologies. Just see if I can zoom back out there. There we go. Don't know what happened. It's because I'm too close to the bottom of my page here. Apologies. I just need to. Just going to have to draw another line over here. Otherwise, I can't write down here because it keeps bringing up things. So if I square root both sides here, I get x plus 3 is equal to 5, but don't forget your plus minus, and then take away that 3. So x equals minus 3 plus minus 5. So again, I'm just going to write next to here I square rooted, and then next to here I took away 3. You don't have to write those in your test, it's just so you know what I've done at each step for now. So x equals minus 3 plus 5 is 2, or x equals minus 3 take away 5, which is minus 8. And that's those two answers done. So these two I then just put in a nice big square, say an examiner, here's my answers, thank you. Hope that helps. Again, there might be multiple ways of doing these. I've done it in the way that I see the fastest approach.